Unit 1 Chemistry, Chapter 9, we're looking at organic compounds. So organic compounds are ones which are carbon containing, naturally occurring at their root. Doesn't mean you've got them from a natural source, but you can find them naturally. And naturally when they do occur, you get them from plants and animals most of the time. Okay? The reason it's based on carbon is because carbon can make 4 covalent bonds. Sorry, that should say bonds. The molecules are basically entirely nonpolar, so therefore they don't dissolve in water, which means they're not readily reacting, which means they stay around for a long time. And it can bond with itself to make complex structures. And we'll look at some of those structures here. Okay? Carbon itself can make chains, or it can make rings of carbon. With other carbons, it can make single, double, or triple bonds. Okay, you don't get quadruple bonds between one carbon and another, so you don't just get C2. But you can get single, double, or triple, and do quite commonly. It can also bond with other common non-elements that we see around a lot. So oxygen, sulfur, hydrogen, potassium, or any of the group 17, which we call the halogens. So it's the basis of life. Yeah. Within your body, the things that are controlling you, so your DNA, your proteins, the carbohydrates, they are all carbon-based. And we've also exploited them to make synthetic materials, which we normally call plastics, but which are generally carbon polymers with desirable characteristics that we need. So we'll look at the simplest ones first of all. Hydrocarbons, which have got only carbon and hydrogen in them. Okay? They can either contain a benzene ring or not. Okay, that's a ring of carbons. We're going to look first of all at these ones, which have got the alkanes, the alkenes, and the alkyls. Okay, so these hydrocarbons, 2 elements only, they can have single or double bonds, or even triple, and they can be in rings, in chains, or even branch chains. Okay. If we talk about a saturated hydrocarbon, that means it only contains single bonds. An unsaturated one has got at least 1 double or at least 1 triple bond in them. So our simplest ones, our saturated ones, with only single bonds, we call the group the alkanes. So any molecule which has the ending ANE, that tells you it's only got single bonds. They have twice as many hydrogens as carbons, plus 2. So the general formula CnH2n plus 2. So if N is 2, like here we've got 2 carbons, number of hydrogens will be 2 times 2 plus 2, so 6 in this case. The alkenes are similar, but they have a double bond in them, and they have the ending ENE. So if you see ENE at the end, you know it's got a double bond in there. It's got 1 carbon-to-carbon double bond, so they're unsaturated. And here, the number of hydrogens is twice the number of carbons. So this one, 3 carbons, 6 hydrogens. And then we've also got the alkynes. So the ending YNE tells you there's a triple bond in there. Okay? Again, they're unsaturated. And their general formula is C to the N H2n minus 2. Okay, so if you've got 4 carbons, then you've got twice as many hydrogens, take 2 away. So 6 hydrogens here again. Okay. The homologous series is the set of organic compounds. So an alkane is one series, alkene is another, and alkynes is the other. The members of the homologous series all differ from each other by a CH2. So if you've got one which has got 2 carbons in it, and then you add a CH2, you get 3 carbons and a couple more hydrogens, and that's the next member of the homologous series. So you can keep on adding CH2 each time. They'll have similar chemical properties, so they'll do the same sort of reactions, but their physical properties, things like whether they're liquid or gas at room temperature, things like what they dissolve in, will change slightly within them. So here we see a comparison between them. Alkanes are common, we normally use them as fuel. So in petrol, for instance, and diesel, there you will see them. They're quite unreactive. Alkenes are less common. They're more useful though, because they're more reactive. And alkynes, very useful, very reactive, also very uncommon, unfortunately.